The owner of a $65,000 house pays $825 in property taxes. Assuming the same tax rate, determine how much tax the owner of a $150,000 house would have to pay. In the initial reading of the problem, I understand the general context is comparing the value of the house and the property taxes paid for that property. In the first sentence, we've been given a comparison of a home's value and the particular property taxes paid for that house. Specifically, we know a $65,000 house is going to be compared with $825 in taxes. This ratio of home value compared to taxes will become important later on. Again, reading through the problem one more time, we can identify that the question we're trying to answer is to determine how much tax the owner of a $150,000 house would have to pay. That will be what the variable needs to represent. So we will define the variable t to represent the amount of tax the owner of a $150,000 house would have to pay. We are going to specify that this tax value will be measured in dollars. Now that we have a variable to represent the answer to this question, the unknown in this particular situation, we need to set up an equation to solve. The equation again will set up one ratio that has everything known compared to a ratio that is missing a key piece of information. The ratio that we know compares the $65,000 house to the $825 taxes. It's important to remember we're putting the house value up top and the tax value in the bottom. When we go to set up this second ratio, the second ratio needs to have the same structure. In the second situation, the question is about how much tax. Well, the taxes are identified in the bottom of the ratio, so that's where I'll put my t, my unknown. The house value is in the top of the ratio, and we do know the house that we're looking at is a $150,000 house. So the proportion that we need to solve is 65,000 compared to 825 is equal to 150,000 compared to t. So the equation 65,000 over 825 equals 150,000 over t. Following the standard process we use for solving proportions, I will multiply both sides of the equation by both denominators. So each side will be multiplied by 825 and by a t. On the left side of the equation, the 825s cancel out. On the right side of the equation, the t's cancel out. This leaves us with the equation 65,000t equals 150,000 times 825. I would not be inclined to actually calculate out what 150,000 times 825 is, because I know for myself I'm very likely to make a mistake when I write that number down. So I will leave it as 150,000 times 825 equals 65,000 t. And to solve this equation, we need to divide both sides by the coefficient, 65,000. Now when we go to do this calculation, you'll notice the right side of the equation, 150,000 times 825 divided by 65,000, is a little bit messy. But that will be taken care of by the calculator. I don't need to worry about any individual intermediate calculation. Bringing up our scientific calculator, we can now complete the calculation. 150,000 times 825 divided by 65,000. And we can see that the calculator returns this value is about 1,903.846, and the numbers keep going. Keeping in mind that we know we're talking about the context of money and paying taxes, we know that the dollars will stop at the penny. Because after the decimal we have 846 and we're going to round it to the penny, that 4 will be rounded up to a 5. So our answer will become $1,903.85. When we write this down on paper, we need to be very careful. We need to recognize or represent in the symbolics that that value is rounded. So I'm not going to say t equals $1,903.85, but I will say that t is approximately equal to. We'll use what I sometimes refer to as the squiggly equal sign to say that this is an approximation. Given the context, it has to be approximated to the penny, but symbolically we need to represent the fact that these two values are not exactly equal. They're very close, close enough for the context that we're working in, but not actually the same. As always, I do want to check to make sure the answer we came up with does fit the context. So what I want to do is compare what is 65,000 divided by 825, and is that actually equal to 150,000 divided by 1903.85. So again, we'll bring up our calculator and do this calculation. On the left side of the equation, we have 65,000 divided by 825, and our calculator returns 78.78787878, repeating. When we write this down in the check area, I will write it as 78.78 with a bar over the 78. Clearing that out, now typing in 150,000 divided by 1903.85, and you'll notice our answer is not the same. It is not 78.78787878, but you will notice it's very close, 78.7877. The reason the answer is not exact goes back to the fact that early in our work, we've already approximated this value. So when we check an approximated value, we're not going to expect to see exactly the same value, but it is approximately equal to the number that we had. And so for us, we know, given the fact that we had to round, this is actually the correct answer. $1,903.85 is the correct answer to the question. Perhaps when I write this down on paper to show that the value did actually check out, I'm going to put an approximately equal there as well. So I'll write what we have there, 78.78 with the bar over it, is approximately equal to 78.7877. Again, I want to be careful to not say that these are actually equal, but it does check out given our context. The final thing to do is just to answer the question. Determine the amount of tax the owner of the $150,000 house would have to pay. The owner of the $150,000 house would owe $1,903.85 in taxes. One other thing to point out with the approximation is, while I did approximate this answer, when the person goes to pay the taxes at the tax office or the tax bureau, they need to know exactly how much to write the check for. So while we did approximate the calculation, I'm not going to mention the word approximately in my answer. There has to be an exact value that this person owes for their taxes, and so therefore it has to be exactly $1,903.85 in taxes.